Okay, so it's time to move on and move forward. Okay. I am a believer that you get out of this what you put into it. If you put very little effort into it, you're probably not going to get a lot out of it. That's just something that I think reigns true. And I think a lot of you would agree with me. Okay? Maybe you don't want to point it out or admit to that. But there again, I think this is something that I'm not going to repeat myself. Okay. So when it comes to chemical bonds, we have illustrated that. Okay. Dot diagrams. Moving on. Now, similar to that. We'll illustrate that as we move forward. Okay. And you can take your two, please. They did, and they have. No, thank you. Okay. So I don't know why this is not lining up. Hopefully that will line up as soon as we move forward. Okay. Now, when it comes to this, a lot of the aspects to this, okay? Okay. As we move forward, a lot of this is simple addition and simple math. You might think, oh, we're going to rush through this, but it's easy to make a mistake. Okay? So with this, as we move forward, we're going to start illustrating what we call chemical formulas, because once you do that, you're creating a bond. Okay? So you can see just the dashes on there. I'll have to talk to Mrs. Preheim. I don't know why this does not line up, but it gives you an idea. Okay? Well, okay. Well, old 69? Is that like a good flavor? I don't know, but you can. Again, I'm asking nicely. Put that away.
I can't eat food.
I think you've had enough.
That's my lunch.
Okay. Besides, we're moving on. So when we talk about the alkali metals, what is an example of an alkali metal?
Potassium.
You're right. Why is potassium one? It's in the first column. Okay. So when you visualize that, how many valence electrons does potassium have? Just has one. So what we are referring to, what you learned last chapter with these Bohr models, these valence electrons become more important. Not all of them, just the valence one only, or valence ones, whichever way you want to look at it, or refer to it.
You can use sulfur to make bombs.
Mm-hmm.
Hey, you took my good meat. Don't take that one. Oh, that hot scanning meat.
I had an article from Reader's Digest, and it had different segments on there, and it was entitled Red Lining. And maybe this is it here. No. But one of the aspects to that, I don't think we have any farmers in here that use manure pits, if you want to call it that. Okay. Right. It could be with pigs, or swine, or it could be cattle / bovine, whichever. Okay. Or if you work at a sewage treatment plant, okay. An example of that is, of course, you would refer to it as sewer gas. Okay. Part of the problem with that is just like carbon monoxide. What do you know about CO or carbon monoxide? You can't smell it.
You can't see it.
And you can't see it.
You can feel it.
Well, you just don't know that you can feel it because the symptoms of that are maybe what you would not expect. Okay. So when you talk about carbon monoxide, do you know what it does to the human body? Well, it's going to give you an extreme headache. That's true. Okay. Does anyone else just have a guess? What? Yeah, it gives you a headache. Why would someone feel really, really tired? Because you're not getting enough oxygen. Okay? Now, I wouldn't expect you to know that. That's why we're talking about this. Okay? Okay? The reason for that is, does anyone know how oxygen gets distributed through your body? Yes, it's in the blood. I get that.
It pumps it through your lungs.
I know that, but it has to bond to something.
It has to bond to your carbon dioxide.
No. Can you donate blood yet?
No.
Okay, so let's go under the presumption that next year or that you could now. What do the phlebotomists, that's what they're called, what do they have to test first, do you think, before you can give blood?
They have to see if you have ligma.
The type.
Has to test your iron levels.
Do you know what ligma is?
Okay?
I want to make sure they don't get too low.
Okay? Because if your iron level is too low, that means your oxygen level is probably low too. That's what we call being anemic. Okay? So this is an example of a chemical formula. Okay? Let's look at it this way. Okay? What column is oxygen in? What column is oxygen in? What column? The sixth column. Okay? So this is... Okay, do you want this information or not? Well, you're making it really difficult. Okay? So based off of prior knowledge, what's the atomic number for oxygen? Okay, when you're saying 4, you're talking about the P block. Okay? But for the entire energy level, there is 6. This is what we're talking about when we're making chemical bonds. We are concerned with the valence electrons, those in the outer energy level. So, if iron forms a +2 charge, does that mean that it has 2 more electrons or 2 less electrons? 2 less electrons. So, therefore, it forms a +2 charge. Okay? Iron. Okay? So now, what type of charge does oxygen want to form? In other words, this has 6 electrons in it. How many can the second level hold? So it can take 2 more. So what happens is if oxygen has 2 more electrons than protons, what type of charge is that? So therefore, that's a -2 charge. Okay? So the charges when a compound forms has to add up to 0. Yes?
Why did you put 2 E's and not?
Okay? It's because it's gaining those 2 electrons from the iron. You can put 2 in there. That's fine. Okay? So now, since these charges add up to 0, that is a type of compound. For those of you who have any type of metal that is outside and is exposed to moisture, this is a different type of iron. That is rust. When iron oxidizes, that's why we call it rust. Okay? All right? So now, we will be talking about things like this as the chapter proceeds. Okay? Now, getting back to this sewer gas. Okay? What happened, I think it was a dairy farm in Virginia. Okay? So what had happened was, it's very common to move manure from one pit to another. Well, it's possible. But what happened is, in that transfer, it became clogged. So it's giving off hydrogen sulfide gas, and that is very poisonous, because what happens is that sulfur replaces the oxygen on there, and you slowly you asphyxiate yourself. It's like if someone puts a sleeper hold on you, okay? If your blood cannot get to your brain, that's a type of asphyxiation. That's what's happening here. If this bonds to sulfur instead, which it does, that's why people can succumb or pass away from hydrogen sulfide gas. Because, again, that sulfur replaces that oxygen, and they slowly asphyxiate, which means they suffocate. All right. Okay, I want to do one more slide, then we'll go back to what it was we just saw. Okay?
That's my bigger deal.
I need to save this for my sister.
I literally jumped this. She wants one of them. Like, I think my cousin wants one too. Big one.
What about Clifford?
Clifford gets all of them. Nick, are you going to Brookings tonight?
No. Unless kind of much.
Okay, so we will illustrate some of these chemical formulas here in just a moment. I'll give you the opportunity to write, process this information down.
I like smelling blown head gaskets. Do you want to erase your outline? Yeah. Like some pinks.
Some pink slips.
Really, I'm just shaking my head no, because no.
You guys never heard about this? How much horsepower you got on that? We'll stall it for 30 years. I need to add more power so I can get more horsepower.
Chromosomes, you mean?
You know, okay. So, now, as we look at this, we're going to look at some of these chemical formulas. Does everyone have this content that wants it? Now does everyone have this content that wants it? Okay. So, to me, if you don't understand this the first time through, that's okay. But if you're trying to catch up from behind, you're just making it that much more difficult on yourself. Why would you want to do that? I don't know of anybody who would want to, but some of you, you choose to do that. Okay. Now, this part, this is just prior knowledge. You don't have to write this part down, okay? Okay. Again, this is based off of prior knowledge. Okay. Again, this is based off of prior knowledge. This is what we learned last chapter, correct?
Correct.
Okay. So, what is a valence electron or electrons?
The one in the last piece.
Okay. So, what we are illustrating didn't we just have this conversation? We just said if you don't catch this the first time around, you're just making it way more difficult on yourself. Some of you, you just make that decision. Okay? So now, since sodium has one valence electron, that gives that one dot is that one valence electron. This you might want to write down, these dots and X's. No. Then when it comes to chlorine, how many valence electrons does it have? It's got 7. Okay? So typically, the best way for you to understand this is show X's for where it comes from one element, dots where it comes from another. That's all that means. Okay?
Okay, so you're going off the number of valence electrons.
Yes.
Okay. Then if the one has 7 and then
Sodium has one.
Okay? Here is the dot. Here is the X's. Okay? Because of what's in the outer energy level.
So why'd you put that X right under the dot?
Okay? Because you need to make a bond. We're forming a chemical bond. Okay? Because
So if Na had 2, then you would put 2 dots.
that's a little, we're not that far. You would, but it's a little more complex than that. Okay? So really what this is illustrating, if you want to, that's forming a bond. To me, this is just a little more confusing. Okay? You're forming a single bond. That's all that means. It means the exact same thing. But to me, I think in your case, it makes a lot more sense with that top example. Okay?
But there's no difference.
There's no difference.
Can we do sulfur and magnesium? We're not done yet.
Sulfur, and why would you want to do that? We can.
Silly goose.
Okay. Well, if that is the case, please stop that. How many electrons or valence electrons does sulfur have?
69. 6. I was close.
Okay? Outer energy level, 6 X's. Now, it doesn't matter if you use dots, if you use triangles, E's, X's, whichever. So, magnesium being an alkaline earth metal, how many valence electrons does it have?
Or 2.
Okay? And remember, the column that it falls in tells you how many that it has. Okay? You're trying to satisfy an octet, the number 8. If it's a non-metal, you want to get 8 electrons around it, whether it's its own.
Why this time did you make a circle instead of? It's just
What? This? You wanted magnesium. Oh, you said sulfide, didn't you? Okay. I thought you said oxide. But we don't have to change anything. What column is these two elements in? It's the only difference.
So you put 6 X's because it's
It's column 6.
And the 2 dots are for the valence section.
For magnesium, which is in 2. That's right. Okay, last thing we're going to do. A chemical formula tells you, okay, who's ever chirping, please stop. All right. Okay.
3 of my votes.
So, this tells you what atoms you have and how many that you have. Okay, so the atomic mass for iron is what? 55.85, right?
Big gizzard in my face.
Is that right?
There's a tiny lizard.
You have to write this down.
I would, yeah.
Oh, you would? You should do that.
Okay. What's the atomic mass for oxygen?
Oxygen's gonna have to be
15.9.
Okay, so we're going to say 16.
I don't even know what I'm looking at there, bud. So I'm just gonna pass
Why'd you do oxygen?
Because it's right there.
Oh, it's in. Oh, that's. I thought you just read that for a circle.
Nope. Okay.
we need to get that looter in you.
Quit making them like I'm
Okay, why did you make the oxygen
Stop
a
cussing.
normal, like a no decimal number, but you didn't do that?
Well,
because they're relevant. It's the atomic mass.
that's what the atomic mass is.
How'd you get that? I'm just.
Why didn't we just say, please stop that?
It's the looter. It's literally the turkin of that.
Yeah, this is oxygen. We just rounded up to 16.
Oh, where's the oxygen?
Yes.
How did you get the plus 2 minus 2?
Where's the oxygen
Okay.
on the what? Board. Oh,
Shut up.
Tickle my country to light beef steak.
Wait, Kenny, is the plus 2, does it tell you that in the box? It's like the first number that's the one.
Yes. Or it could be the second one. Because charges have to add up to 0. Okay? We just haven't gotten that complex yet. We're trying to take this slow. All right? Okay?
Are you always gonna add this?
All right. So we'll pick up with this content tomorrow. The last thing I want to show, some of you saw that I had this in here, because after this we deal with chemical reactions, and that's what this is. Just an example. Okay? So all you're doing is pour this in here, and it forms a white precipitate. I don't know if you can see that on there, but it was clear, and eventually that will fall out of the solution and forms, again, a precipitate. That is what the juniors are working on now, because you can make calculations based off of that. And that's what we're doing. Okay, we'll catch up to you next time.